In this class, all of the vectors we use are going to be in 2D. And that simplifies things a lot as opposed to the calculus-based version of this class where you can have three-dimensional vectors and higher physics where you can have multi-dimensional vectors. But in 2 dimensions, one way we can think about a vector is if we have some circle, and let's draw our xy axes centered on the center of the circle. And so now we'll draw some vector r, which is going to make some angle theta with the x-axis. Okay? Now, any vector we draw that has length r is going to lie on this circle. The only difference is they're all going to have a different angle theta. So in other words, the radius of the circle r is the magnitude of the vector. Now what about theta? Well, let's see. We know that sine theta is the opposite over the hypotenuse. Okay, so what's opposite theta? Well, that's going to be ry. And what's the hypotenuse? That's capital R, right? That's the radius of the circle. So in other words, the y component of r is just going to be the radius times sine theta. Now this is true even if we're not thinking about it as a circle, right? It's just, this is the magnitude of r times sine theta. I'm just giving you another way to picture this in your head. All right, well now what about x? Well, we know that cosine theta is the adjacent over the hypotenuse. Let's see, well the adjacent is rx. And once again the hypotenuse is r. So in other words, the x component is r cosine theta. Right, or in other words, the magnitude of r times cosine theta. Now, what if we want to know the angle? Well, we saw this in the last video, right? We can say tangent of theta is going to be the opposite over the adjacent. So opposite is ry, the adjacent is rx. So in other words, theta is the inverse tangent of ry over rx. Now keep in mind, it doesn't have to be this way. We could have started with something different, where maybe our coordinates were such that we still have x and y in the same directions. We still have the same r, but maybe this time theta was given from the y-axis and not the x-axis. Now this is a realistic scenario that you're going to come across sometimes in this class. And one of the most common mistakes that I see students making is always using rx is r cosine theta, ry is r sine theta. And that's not true, right? In this case, rx is not equal to r cosine theta, right? Because if we look at this, remember that cosine theta is the adjacent over the hypotenuse, which in this case is going to be ry over r. So in this configuration, ry is going to be r cosine theta, and rx is going to be r sine theta. If you don't see exactly how I did that, pause the video, maybe go back and rewind it and watch that part again, and make sure that you can convince yourself that you believe this. And I really can't stress this enough, because even though you're watching this video and I've gone over it with you, there's still going to be a percentage of you watching this that in the first exam, you're going to sit down, you're going to have something that looks like this, and you're going to write down Rx equals R cosine theta, because in most cases, that's the coordinate system we're using, where the angle theta is coming from the x-axis. But that's not always going to be the case. So, make a mental note right now that you always want to check which axis and where the angle theta is, and make sure you know and understand how to calculate Rx and Ry properly.